Welcome to part 1 of the Advanced Concepts in Choice-Based Conjoint webinar, hosted by your friends at Sawtooth Software. My name is Megan Peitz, and my colleague Brian McEwen and I will be leading you through this webinar, covering topics including the dual response none, constant sum, conditional pricing and display, as well as alternative specific designs. We're really excited to talk to you about all the possibilities of Choice-Based Conjoint in Lighthouse Studio. So let's get started. All right, so we have a lot to cover today in part 1 of our advanced topics in CBC. We're going to do a lightning review of CBC. I recognize some of the names on our attendees list, so thanks everybody for joining. And some of you might be new to CBC, so there's a couple of things I want to go over, some of those nuances and semantics that I'll be saying that you might want to know what I'm talking about. So we'll do the lightning review, and then we'll jump into the guts, the dual response none, our constant sum or chip allocation, conditional pricing and display, and alternative specific designs, all really powerful tools in choice-based conjoint analysis. But first, what is CBC? So CBC came around in marketing research in the early 90s, and if we look at our users at Sawtooth Software, about 75% of the research that our users are doing of market research are doing is 75% of conjoint type research. And rather than rate options in a survey, respondents are simply asked to choose which they prefer. So we have this tourism example here, and we have 3 different vacation packages as well as a none option. So you can see that we can either go to San Francisco for 5 nights, Washington, D.C. for 3 nights, Las Vegas for 7 nights, or maybe you would prefer to not go on vacation rather than choose any of these. Now you can see the different attributes on the left-hand side, destination, number of nights, accommodation, etc. And then within each row, you see the different levels associated with those attributes. And you can see that by forcing somebody to make a choice, we can really understand what they truly value. So in addition to that, why do we like it? Well, it's a lot simpler for respondents because it mimics what they're doing in real world. We get better data if the way that we gather our data actually matches reality. The other piece is people are going to be less likely to have respondent fatigue when we keep asking these ratings grids over and over and again. And let's not mention the response bias that can come with rating grids as well. One other cool thing about conjoint analysis is we get probabilities in versus probabilities out in choice-based conjoint. So you can see in the last example, we had these 4 different choices essentially, all things being held equal, maybe each has a probability of being selected 25% of the time. We'll learn over time that maybe you really enjoy going to San Francisco, and so that has a higher percentage of being chosen than 25%, but you can see that there's this probability going in of selecting each of the different vacation packages. And therefore, when we predict something, we get probabilities out. We can say, hey, if we were to give you these 3 different vacation packages, which would you choose? And we would get a share of preference or a probability based on those 3 different vacation packages. And the main reason we're here today is with choice-based conjoint, we get flexible design and analyses. So we can use many different applications, and some of those we'll be touching on today, if not in part 2. So let's get started. The first one we're going to talk about is a dual response none. So in the previous vacation example, I showed you the none as a concept, right? It could be chosen amongst each of the other 3 vacation packages, or you could have chose none. But in the dual response, rather than including none as a concept, we're actually going to split the question into 2. So first, we're going to ask respondents to choose between the alternatives, not including the none. And then we're going to have a follow-up question where we would ask them if they would actually buy the product that they selected in the choice exercise. So here's an example below. We're going to ask people which of the following computers do they prefer. So you can see your Apple, your Dell, and your Lenovo. And then once I make that choice, Given your knowledge of the market, would you actually buy the option you selected above? And I can click yes or no. So some of the benefits of the dual response none is that we're getting more information and being more efficient. So we actually get to learn about everybody's preferences with greater precision, even if all the alternatives are poor. So sometimes I really like the dual response none when I'm tempted to believe that my respondents might choose the none option more often than they would choose one of the alternatives. And when they choose the none option, I'm getting some information, right? But I'm not learning about the actual attributes and levels that I'm really concerned about trading off in order to build my perfect concept or my perfect product. The other benefit of dual response none is that it actually increases the utility of the none. So that none threshold becomes higher when you ask it this way, resulting in a larger share of preference for the none in the market simulator. And that higher threshold is probably more realistic than the traditional none weight or when we ask it as a concept. Another part that might help that none threshold be higher is that when we do a dual response, respondents don't feel obligated to choose a product just to be helpful. You know, many of our respondents are panelists, right? And they're used to seeing conjoint analysis, and they kind of know what you're getting at with your surveys. They know that you want to learn how to design the best product or service, and they know that they get to help you in that decision. So oftentimes they're going to try to choose something that's going to help us as researchers, such kind respondents that they are. And they feel like answering the none is not helpful, and so they're tempted to, you know, make another choice. Some research on research done in 2003 told us that the dual response leads to none choices 3 to 4 times higher than the traditional none as a concept. So that's something to really think about when you are designing your CBC. Just a couple more benefits. It reduces the incentive to click through just to get done because you have to choose amongst the ones that you are given and then also decide if you would actually purchase it. So you have this secondhand process of thinking through things. Can't really speed through it. And of course, better information leads to better individual level utilities. But of course, there are going to be drawbacks, right? We are in the business of trade-offs, so there will have to be things that you will consider when you choose a dual response none or not. So an obvious one is that it is going to take longer. It's twice as many questions to answer, right? And it still doesn't necessarily lead to accurate take rates because we're still only testing usually a subset of attributes that describe the whole product. We don't have other influencing factors like awareness, distribution, etc. We can model those with the simulator, but there's still this need of getting accurate, quote-unquote, market share presentation. And with the dual response none, it can't be used for chip allocation, which is another one of our concepts that we'll be talking about in just a bit. But the great part is that it's super easy to do in Lighthouse Studio. So if you are familiar with the platform, which we will jump into in a little bit, when you design your CBC exercise, you click on the Design tab, and in the design settings, there is a spot for the none option. The default is set into traditional, which would be the concept, like in the travel CBC that we showed you up front. But all you have to do is toggle to dual response, and then you can click on the settings option and actually give a little bit more text. Maybe you want to change it to, you know, given what you know about the marketplace, would you really buy the computer you chose above, a yes or no? So those are how you would do it in Lighthouse Studio. And I'm sure some of you advanced researchers out there are saying, binary, okay, that's pretty good, but what about a 5-point scale instead? So, you know, hesitation, right? You're introducing your scale bias again, but 5-point purchase intent scales, people are very familiar with. They kind of know how to use them, and you can do a little bit more with the information, right? Maybe you want to look at the analysis just using top box or top 2 box or some sort of 80% top box, 20% second box and things like that. So it gives you a little bit more flexibility on how to use the data in the dual response. Because we only have an hour today, I'm not going to jump into that type of coding, but when you get the materials, you can click on the hyperlink here to see how to do this in Lighthouse Studio, and make sure to check out the 2012 Sawtooth Software Conference paper by Kevin Carty, Much Ado About Nothing. All right, so that was dual response none. So now we move to constant sum, or more prevalently referred to as chip allocation choice-based conjoint. So why would anybody want to go with a chip allocation CBC? So there are some issues when we do a standard CBC task. We have limited information, really, right? We're asking them, of these 4 concepts or products or services, which would you choose? So we know what's preferred, but we don't necessarily know how much it's preferred over others. Yes, we'll get that information when we add up the utilities and things like that, but there's some more information that we could gather from them in terms of their own personal preference for how much each is preferred over the other. Plus, as researchers, we might say, well, we're paying for these people to take this survey. They've already read all these descriptions. Are we really going to let them off that easy with just having to click one button and make one choice? Of course not, right? There's also some assumptions that we make with standard CBC tasks. We're assuming it's just a single purchase. So given these 3 products, which one would you choose? I choose this one. Just one point in time single purchase. We're also not assuming any variety seeking behavior, meaning that we're assuming that every time they're presented with these 3 concepts or these 3 products or these 3 services, they are always going to choose option A or option B. But we know when we go to the grocery store and we're looking at cereal, maybe Cheerios is my favorite, but today I have a sweet tooth and I want some Frosted Mini Wheats, but I can't capture that if I'm only asking them at this point in time. I'm not allowing them to seek variety. We're also assuming that the usage situations are identical in a standard CBC task. So with chip allocation CBC, rather than asking respondents to pick the best one, we're going to request that they allocate chips based on some criteria that we come up with. So these chips could be, in my example, boxes of cereal. You could, if you're doing pharma or medical research, you could talk about number of patients at the doctor's office. And the really great thing about the software is that the criteria you choose can either limit the decision space or leave it open-ended. So if you have a limited space, an example would be of your next 20 visits or of your next 10 purchases, or out of 100%, what is your preference, things like that. And an unlimited space would be of your next trip to the store, how many different boxes of cereal you're going to buy. So I might, I have just my husband and I, so I might just buy 1 or 2 boxes of cereal. But Brian has a family of, himself and 5 others, so he might buy a couple more boxes of cereal than I would. So we would have different decision spaces. So a chip allocation example programmed in a survey could look like the following. Here we're asking about soft drinks for a party with 20 of your friends. So maybe you have friends who just crush soda pop all day long, lots of Mountain Dew, lots of Coca-Cola, and so you're going to have a higher number of purchases versus maybe your friends really like water and aren't interested in soda, so you only buy maybe 1 or 2 soft drink packages. You can see people are going to have different decision spaces here, and they're going to fill in the quantity that they're going to purchase below each item. Again, we make it hopefully very easy for you to do this in Lighthouse Studio. Underneath our response type, instead of choosing the default discrete choice, we're going to choose the constant sum/chip allocation setting. And you can see a little example to the right where we are asking them to either sum up to 100 or give us a percentage preference or something like that. Down here below, you have your advanced settings where you can limit the decision space. So in this example, it's limited to 100. And there's also some other kind of formatting tricks and tips. You can also insert a total label, which is very helpful when you do have a limited space, right? Because you want people to make sure they get to 100 or to the 10 cereal boxes, etc. So some benefits of chip allocation is we're going to get more data from one choice task, right? We're asking people to assign numeric value to each of the concepts that we're showing them. So in a typical standard CBC, we show them 4 concepts and we have them choose one. We're really only getting information on that one and that it's preferred to the other 3, but we don't know how the other 3 compare to each other. Now that we have chip allocation, if we have 4 concepts, we get a numeric value associated with each of the 4. So we're getting more data from one choice task. And this actually allows us to decrease our sample size requirements. There's also potential here to gather volume purchase data, which is really helpful when it comes to some of those fast-moving consumer goods. If you think about soda pop, cereal, anything else that's a very common purchase. And it allows respondents to indicate preference for profiles that have some benefit or that are valuable for certain usage situations but might not be their primary choice. So I talked about the example of how I would typically buy Cheerios, but on occasion I might be feeling, you know, like I deserve some Frosted Mini Wheats. So Frosted Mini Wheats aren't going to be my primary choice, but if the price is right and the Cheerios are too expensive that week or something, I might have a couple of situations where I'm going to choose a different product than my primary choice, and chip allocation really helps with that. But again, there are always drawbacks, right? It's going to be more work for the respondents. They're going to have to acknowledge each of the concepts and then give weight to each of them, right? And if you know me at all, I'm a mathematician by nature, but I am terrible at simple math. And our respondents, if we have a limited choice set or decision space, they're going to have to know how to add. And that's kind of tough sometimes. We can put a total on there, right? And they can eventually get there. We could show our error messages, but we might frustrate some people if we have a really hard number to attain that's not easy. Or people might simplify, and if we're asking them to do sum up to 100, they might just do 10, 20, 30, 40 to make it very simple for them. So we got to be careful about some of those drawbacks there. We also don't really know why they allocated the chips to the multiple products. We don't know what's going on in the background, right? We don't know in the instance of pharma or medical, if doctors, when they're giving chips, are they thinking about the different patients that walk through their door every day? Are they thinking about the insurance inequalities? Maybe some people have commercial insurance or individual insurance or Medicare, Medicaid, and that's how they're allocating their chips. Again, you know, there are much of different ways that people could be thinking about how they're allocating their chips, and we don't really know why. The other thing is that in the analysis, we have to specify as the analyst how we are going to count those choices. So if somebody gives 60 chips to concept 1 and 40 chips to concept 2, are we saying that out of 100 votes that's 60? Or are we saying out of 10 votes that's 6? Or are we saying out of 1 vote, concept 1 has a 60% choice of being, or 60% chance of being chosen, and concept 2 has a 40% chance of being chosen? And just these little nuances can make a difference in what your output actually looks like. So that is something that you will want to think about in the analysis phase. But there are ideal times when you should use it. So if you run into situations where you do not have large enough sample, oftentimes we might recommend adaptive choice-based conjoint, but here chip allocation would also work really well. So pharma studies I'm typically doing with maybe 30, that's really low, or 50 or 100 respondents. Using chip allocation would be a great result here, or when we have alternative specific designs, which we will talk about later as well. There are also situations where respondents are going to make multiple purchases in a single transaction. So an example, again, we talked about soda pop at the grocery store. Depending on your family composition or what you're purchasing for that week, you may be buying multiple different purchases in one transaction. And so by forcing them to only choose one, we really can't represent those multiple purchases. And then lastly, when repeated decisions are par for the course. So doctors are prescribing medications, on a daily basis, right? But each medication they prescribe is specific to the patient, and not one medication is going to satisfy every patient's needs. So they are very familiar with, prescribing different medications to different patients, and it's really par for the course. So this is when chip allocation really makes sense. When we think about the analysis phase, I kind of alluded to how you have to verify how you're going to bring the chip allocation results into the software. But you also need to be using HB, hierarchical Bayes, or latent class procedures for the analysis. So we bring in the chip allocation data, and then we weight the tasks based on how we decided to define them in our analysis program. And then our resulting utilities are going to be scaled the same as standard CBC, which is awesome, right? Because now we can predict the probability of that allocation and use a market simulator, one of our most powerful tools from choice-based conjoint analysis. Now, some of you may be asking, hey, well, this is great. My client's constantly asking me about volumetric CBC and how can I use that information? And, we'll be the first to tell you we don't really know what the best solution to this is, because it's really a tough thing to kind of think about and make sure you're encompassing all of the different attributes that come with volumetrics. But one approach could be what we recommend is don't include a none in the survey. But then when you get the data back, you can go in and modify the CHS file. So you're going to have to do some, advanced techniques to kind of open up the CHS file and get your hands dirty in the data and include a none concept. Then what we do is that within each respondent, we look for the task that has the largest volume purchased across all concepts. So this is ideal when you have the non-limited decision space, right? So maybe for respondent 1, they have a largest volume across all tasks as a 15, and maybe for respondent 2, the largest volume is only a 5. So we're going to call that amount V for volume. And each person might have their own unique volume. And we're going to set the none allocation to 0 for that task where it has the largest volume. And then for every other task, we're going to set the quote-unquote the none that we've created equal to that highest volume number minus the total volume that we allocated for that task. Okay, so our none is going to have a different value associated with it depending on how different the total volume was associated with each task. And then we can estimate this with CBC HB with Sawtooth software, and we can run weighted market simulations where each respondent ends up being weighted by that V value, and we could also do this in Excel. The great thing is that we have a tool that allows you to mess with the CHS file and insert the none. And we also have, you can open up this PowerPoint and click on the link there to get that converter so that you can get around and play in there. Okay, so that one was a little bit, because hopefully you can start to see that we're getting more and more advanced as we go. Erin Hill is going to give part 2 of this, and those will be even more advanced concepts, but hopefully you're getting excited about all the possibilities of choice-based conjoint analysis and are thinking about ways that you can use them in your future research. Now, one thing that I am very glad that we have the option for is conditional pricing and display. As a part of the Sawtooth Analytics team, we are doing lots of conjoints weekly, right? And I would say probably 30% of the conjoints, choice-based conjoint exercises that I put together have some sort of conditional element to them. So what is conditional pricing and display? Well, in conjoint analysis, we're assuming that all the attributes are freely combined. They're independent. But we know that this isn't always the case, right? And we know every one of our conjoints doesn't fit into some perfect little box with a nice little bow tie on it, right? I'm from Detroit, so I always think of automotive industry when I think about if I were to see a choice-based conjoint exercise and a Lexus or maybe an Audi S5 with a Chevy Volt, I would expect them to probably not be in the same price range, right? You have your price for your luxury type of vehicles and your price for your more standard type of vehicles. You might also have some size or speed differences. You might also have large differences in feature sets. Or interwoven attributes such as packaging and brand images. And instead of telling the respondent what the individual elements are, you want to just show them one image that represents both of those packaging and brands. So how do you solve this? Well, obviously, the first option would be ignore it, right? But I don't mean that being, silly. There are times when price ranges for a product are quite similar. And you may just be better off with showing some products at sometimes unrealistic prices. But oftentimes when I go with this approach or attempt this approach and I show my client, they say, Megan, this isn't reasonable. This would never happen. And so we go back to the drawing board and we either come up with an alternative specific design, which we'll talk about more later, where in an alternative specific design, we have nested attributes, where some attributes are going to apply to certain concepts, but not to others. Or we take a conditional pricing or display approach, where we still assume that our attributes are independent, but we're going to present the combinations of the products or services in a more realistic way. So in the automotive example, let's say brand is what makes our prices differ. So we have an attribute of brand. Well, and in this example, let's pretend that there's a lot of zeros after those numbers if we're talking about automobiles. But in this example, we have an attribute of brand, right? And we have 3 different levels, brand 1, brand 2, brand 3. And then we also have an attribute of price, and we have 3 different levels there. And we're going to call them, if you could see me doing air quotes, level 1 is low, level 2 is medium, and level 3 is high. And we can include this conditional pricing or what we call lookup table within Sawtooth Software's Lighthouse Studio so that when the survey runs, the software actually inserts the appropriate price depending on the brand. So we fill out this table, and then every time a brand 1 appears, for price, instead of showing the level quote-unquote low, we actually see the price of $12. Versus when we see brand 3 at the low price, we actually see a price of $16. The coolest part for all of you nerds like me out there is that the internal design matrix still reflects just 3 levels of price, which is awesome when it comes to things like parameters in our model estimation. Now, a recommendation when it comes to conditional pricing tables is that we want to follow the theory of elasticity for all of the econometricians out there. We want to make sure that there's a constant percentage change in price from the low to the medium to the high price. Or if we have, 4 levels, we want to make sure that there's a constant percentage change between each of those. The thought behind there is that, the percent change in quantity demanded divided by the percent change of price gives us the ability of getting a really good chance of fitting the model well using only main effects, right? Instead of having to use interactions, which is really nice and allows us to keep our sample size manageable. The minute we introduce interactions, we introduce more parameters, and thus we want a larger sample size as well. So when you're thinking about putting together conditional pricing tables, try to specify price changes as near constant from the average price. So for example, we're going to say the medium level is our average, and we're going to do plus or minus 25% from that medium level for our low and high level. Again, it just gives us a better chance at fitting our model well. And so we would always check for interactions, right? But when they're not significant, we can save those degrees of freedom and model just as good with the main effects by using this proportional approach. And if we don't use a proportional approach, it's going to increase the likelihood that we're going to have to estimate interactions. So if I've scared you enough into using proportional conditional pricing tables, there's going to come a time when you're just not going to be able to use proportional conditional pricing tables. Sometimes this is at client's request, sometimes this is because you forgot afterwards, but as long as the price is conditional on just one other attribute, so let's say brand, for example, then we should be able to model the data correctly using first order interactions, no matter what the pattern of prices were within the table. So bottom line there, if you use non-proportional conditional pricing tables, you're definitely going to have to have an interaction term between price and whatever attribute it was conditional on, and think about it prior to fielding, because you're going to want a larger sample size to account for those additional parameters in the model. But the big warning, the big hesitation here is if you make price conditional on 2 or more attributes and you're not using proportional tables, then you're probably not going to be able to model the effects correctly with the CBC software. So hopefully none of you have run into this in the past, but let's say if you use a price conditional on brand and package size being 2 attributes on their own, and your table is not proportional, you probably ran into some problems. And I think I have a slide here and coming up, but one way to handle this, because sometimes if we think about that Coke example, the soda pop example, right, we have brand, we have package size, and we have price. Package size, Coke may be having a higher price point than the store brand, as well as a 12-pack having a higher price point than a 6-pack. What we can do is combine the attributes of brand and package size into one attribute, and then have our conditional price attribute. So it really only looks like price is conditional on the attribute of brand by package size, and then we'll be able to model the effects better in the software. Hopefully you kind of followed my thought process there. I wish I could write it out for you, a little hard with PowerPoint, but there are ways to get around it if you have to use price needs to be conditional on 2 or more attributes. Or you just use proportional pricing tables, right? If you're using conditional pricing, remember that the utility of the brand is no longer interpreted as what we normally think, right? The preference for this brand, everything else being held constant. We have to change the way that we communicate, and we have to say the preference for this brand given its average price. Okay, so just a little semantics there, but you'll want to make sure you get those correct when talking to a client. Again, super simple to do in the software. On the Attributes tab, you have your 3 attributes of, in this example, brand, price, performance, and price. And we can click on that Conditional Relationships button, and it will open our conditional table. And we can start to put in prices, where we see here Attribute 1 and Attribute 3 are our conditional pricing, so brand and price. And when at Attribute 1 Level 1, at Attribute 3 Level 1, we have price of $4 and so on and so forth. So we fill in that table accordingly, and then every time Attribute 1 and Attribute 1 Level 1 and Attribute 3 Level 1 is shown on the screen, we see $4 instead of, quote unquote, the low price for this example. So I talked a lot about pricing, but the other powerful feature is that you can use this for display as well. So as with price, sometimes we're going to want to show different combinations of attributes in a single representation. So we have brand, we have type, and we have pack. And these are going to combine together to show one image. And on the right-hand side, we also have an example of 4 attributes being combined together into one textual type of description. So this is really great conditional display when you have you want to make it simpler for the respondent, right? It's a lot easier for them to absorb this one image of the Coca-Cola Light 6-pack than it is to read the text of Coke Light 6-pack 12-ounce cans. In Sawtooth software Lighthouse Studio, you can actually include up to 250 attributes in each conditional table in our advanced design module, I believe. You might actually be able to do that in the regular CBC subscription as well. I'll have to double check. But remember, you can only estimate interaction effects for the 2 attribute combinations. So the part where I was talking about before, the brand, price, and package size, if you think there's going to be an interaction between more than 2 attributes, you probably want to combine those attributes together so that you can model appropriately. While our software allows you to include only one conditional price table, you can actually include multiple conditional display tables. And if you have any display tables that have continuous attributes in them, so maybe it's miles per gallon or miles per hour in terms of speed, or time from 0 to 60 in number of seconds, you're going to want to hold to that proportionality recommendation that we make when we talk about pricing when you have continuous attributes in conditional displays. All right, so before we get to alternative specific, I'll take a quick break. Brian, do we have any questions or anything we need to handle before we jump on to the last topic?
Not really. There's just been a couple questions. Like there was one question about the dual response none, and one of the things you'll find that is, especially with me and the support team and things, we very rarely will speak in absolutes. So you know the question was, is dual response none always better than doing a traditional none? And you know, while Megan talked about a lot of the benefits of it, it's very rare for us to say, approach X is always better than approach Y. It's just, there's so many complexities and different studies are so different that we say it depends a lot. And so, I would feel comfortable saying, most of the time, all else equal, I'd probably prefer a dual response none. Or, most of the time, all else equal, if both are viable options, I might lean towards an adaptive CBC just because of some of the cool things it does over traditional CBC. But there's definitely situations where one approach will work better, one approach feels better, or it displays the information to the respondent in a better way. So especially if you come to any of our trainings, that's one of the first things we get out of the way really quickly is we say you can't really give like a 10-step list of do these steps to have a successful project. A lot of our answers are depends, which leads to really great discussions, but a lot of the times there aren't absolutes. You can, if you have fancy pricing, you can do conditional pricing, you can do multiple price attributes, which you're going to cover next as an alternative specific design, and then there's other stuff that we're not going to cover today, but there's things like lockstep pricing and other approaches where, a lot of times things are viable and it can just lead, the answer will come from personal preference and respondent preference and situational preferences and that sort of stuff. So it's all good discussion and just good to know all these things that are available so you can know what your options are when you have the trickier stuff down the road.
Awesome, great addition, Brian, and totally agree. I find myself saying it depends more than anything. All right, so alternative specific designs. So these start to encroach upon the a little bit more complex. You're given a situation and you're thinking, yes, this is a choice-based conjoint, but man, does it feel weird. And I'll get into an example of that weirdness feeling in just a second. But the great part about alternative specific designs is that it gives you a really flexible way to think about CBC. To up to this point, our thinking has really revolved around this idea that we, build a single list of attributes, and all of those attributes apply to every product concept that we show. And this is traditional style conjoint thinking. Nothing wrong with that at all. But sometimes it just doesn't make sense, right? So take this example. For example, we have different transportation methods to get you to work. We have a bus, a car, a train, or you could walk. The bus leaves every 25 minutes in this example. It has a $3 round trip fare, and Wi-Fi is available on the bus. But you can see if you applied any of those attributes to walking to work, well, it might be a little awkward, right? You're going to charge me a round trip fare for me to walk myself to work, or Wi-Fi available. Maybe I have it on my phone, but that's not something that you would offer me as a company. I'm just walking. If I want to access Wi-Fi, that's not my own thing. So same thing, with the train. If I were to the daily parking fee of $10, maybe there's no parking fee to get to the train, but there is a fee for the round trip fare and leaving every 35 minutes. So you can start to see how there are certain attributes that are only going to apply to other attributes or other levels within an attribute. And we call that alternative specific designs. We're talking about these alternatives and the attributes that modify them. So in our example, we have the alternative specific constant of our transportation mode, being the bus, the car, the train, or walking. And then we have these modifying attributes. So when the mode leaves, the round trip fare, if Wi-Fi is available, if there's a parking fee, etc. And the great part about using alternative specific designs is that you get to estimate not only the utilities for those alternative specific constants, but you'll also get estimates for the modifying attributes as well. And by doing this, we can come up with these amazingly customizable designs. The stuff that you can do with alternative specific is pretty cool. I will say it's only available in Sawtooth Software Lighthouse Studio if you have the CBC Advanced Design Module license, or if you have a standard ACBC license. The standard CBC license will not allow for alternative specific designs. Alternative specific designs are a possible solution when you're struggling with too many prohibitions. So oftentimes clients might come to us and say, oh, this would never work for this attribute, and this would never work with this level, and this prohibition list starts to get a little bit out of hand. That's when I kind of take a step back and think, can I convert this into an alternative specific design and get much better results and a more balanced design than if I were to approach it with my multiple amounts of prohibitions. So this is going to be an example, and I'm actually going to open up the software at this point and kind of walk you guys through the alternative specific design and how we reference it in the design phase. So we have our mode of transportation as our last example. We have our pickup frequency, our round trip fare, if Wi-Fi is available, and our daily parking fee. Okay, so a simple solution would be to prohibit round trip fare from appearing with car or walking modes, and to prohibit daily parking fee from appearing with bus, train, or walk. And we could keep going, right? But the standard designer is not going to be able to handle this in Lighthouse Studio. They're going to come across too many prohibitions. So by checking a box that says we have an alternative design, it's going to draw on the alternative design algorithm that's going to allow for these types of prohibitions and create for us a really great design. So the alternative specific designer is activated when we choose it on the design tab, and all the levels of one attribute are prohibited with one level of another. So in this example, on the left-hand side is the bad way to put together a choice-based conjoint, where we have our different systems, iOS, Windows, Android, and our different brands across the columns. And you can see Apple can only ever appear with iOS, and that's really going to hurt our design. But if we can think about it in an alternative specific way and maybe change it so that Apple just, that our attribute for system is only Windows and Android, then we can have all levels of the system being prohibited with one level of the brand attribute, and that is going to be great for our alternative specific designer. Just a couple of special notes. Alternative specific designs can have regular prohibitions. We don't not allow you to have them, but we will tell you that they're going to be very damaging, so we really recommend avoiding these at all costs. And some attributes can apply to all products, while others are alternative specific. An example there would be maybe the time it takes to get to work might be applicable to all of the modes of transportation, right? While the others, when we're talking about round-trip fare and Wi-Fi availability, those are alternative specific attributes. Another note of caution is that you should really test your alternative specific designs using the advanced test within the software and not just the quick test. And I would even go a step further and recommend that you run, generate some dummy data and run that through, and then take a look at your results as well, just to make sure that things are looking good, standard errors look appropriate, each level is seen with each attribute, you know, a similar amount of times within each attribute, and so on and so forth. All right, so let's open up Lighthouse Studio and try to do this tricky Alt-Tab thing. Not a pro. Hey, look at that. All right, Brian, I'm making sure that you can see my Lighthouse Studio software up.
Yep, we can see it.
Great. So I went ahead and put together our CBC exercise just in the interest of time. And so you could see the different attributes, mode of transportation on our levels, bus, car, train, walk. You have our pickup frequency, we have our round trip fare, we have our Wi-Fi availability, and we have our daily parking fee. So if I preview this without anything going on, I can see my mode of transportation, I can see everything has a pickup frequency, I can see everything has a round trip fare, everything has Wi-Fi, and everything has daily parking. So I know that I'm going to want to go in and maybe change this up a little bit. So how do I do that? Well, I click first on this Prohibitions tab. Okay, and this will allow me to create my prohibited pairs. So first, I'm going to click on Mode of Transportation. So that's our bus, train, car, and walk with our pickup frequency. So it will automatically pull in a table as such. And if I kind of hover over each of the areas, I can see that this column refers to the mode of transportation, and this column over here refers to the pickup frequency. So for bus, there's definitely a pickup frequency, but for car, there's not. So I'm going to click on my row, click this fancy check button, and select all of these. And therefore, I have now prohibited car from having any pickup frequency at all. Train will have a pickup frequency, but walking will not, so I will check that too. Then we think about mode of transportation with round trip fare. So I see bus over here, I know that has a round trip fare, but my car again does not. The train has a round trip fare, but walking does not. Mode of transportation with Wi-Fi availability. On the bus and the train, I imagine that you can have Wi-Fi availability. Technically now you can have Wi-Fi available in your car, but since we don't want anybody checking their email or on their phones while they're driving, we will say no to that. As well as for walking, it's not really something that's offered when you walk somewhere. And then finally, mode of transportation with daily parking fee. So the thought would be that you can either walk to the bus station, so there's no parking fee there, but if you drive to work, there'd be a parking fee maybe at the office. Train, maybe there's no parking fee to park at the train station, and of course with walking, no fees at all. Okay, so we've set up all of our prohibitions. So normally we would feel as analysts, yikes, that's so many prohibitions, our design is going to be terrible. So if I go to this design tab and I leave traditional on, I'm just going to slow down the number of versions so it doesn't take forever. And I click generate design. Oops, I got to get rid of my fixed tasks really quick. So the task could not be generated according to these constraints. Please check the prohibitions. So basically, Megan, you failed. You cannot attempt a choice-based conjoint with all of those prohibitions. But if I check this, hey, why don't you try it using the alternative specific design algorithm? And I click generate design. It's giving me a warning about the show attribute labels, which I will talk about in a second. So I'm going to uncheck that, go back to my design tab and click generate design. And now I have a nice little design that is going to work and run for me. And then I can use the advanced test here by testing two-way frequencies and simulating data through it and taking a look at what my data looks like. We'll assume for timing purposes that it looks great, but that's where you can test the design. If I go back to the slides really quick, you can see that there is this align common attributes on the same row. So what that means is that we can actually we can show the labels for our attributes, and then there will essentially be blanks where those alternative specifics do not apply. So in this computer example, our laptop display only applies to the 3 laptop products, where our desktop display only applies to the 2 desktop products. Same with laptop price and desktop price. Sometimes this is nice because sometimes we need to explain what we're showing our respondents. Other times they can probably get it from the information, or maybe we have an intro screen set up, and so we don't align common attributes, and it kind of collapses everything together and makes a little bit more of an equal trade-off. So here you can see that even though I'm not telling you that this is the size of the laptop, you can see that here are all the sizes all in one row instead of like in the previous example, split into 2 separate rows. So when you saw that error earlier, we had the attribute labels checked in the design settings, and so we could not use the align common attributes in the same row. So we just had to turn that off, and then we were able to generate our design. So if we were to preview it really quickly, we can see that we don't have any of the attribute labels over here, but we do have our car, our parking cost, our free parking, but here we might want to include the attribute labels. So if I click align common attributes and I click on show attribute labels and then press OK, now I can see mode of transportation, pickup frequency, round trip fare, Wi-Fi availability, and daily parking fee. Okay, so you just choose whatever option makes the most sense for you. And then finally, I'll just go over the design matrix really quick in the last couple of minutes, because this is really the under the hood action of alternative specific designs. So in our example, we had 4 different alternatives. The labels here reference the attribute number and then the level number. So our attribute 1 is our mode. So bus is attribute 1 level 1, car is attribute 1 level 2, train is attribute 1 level 3, walking is attribute 1 level 4. And then we have our frequency, attribute 2, leaves every 25 minutes is level 2, and then that also applies to alternative 3, the train, leaves every 35 minutes is level 3, and so on and so forth. So down here, when we create the design matrix, using effects coding, we have our different modes of transportation. So attribute 1 and alternative 1 is level 1, so we code that as a 1, a 0, 0. Alternative 2 is a level 2, so that gets coded as a 0, 1, 0. Alternative 3 is level 3, which gets coded as a 0, 0, 1. And alternative 4, which is level 4, actually gets coded as a negative 1 for all 3 of the columns. When we get to the alternative specifics, you can see that they're all coded as zeros when they do not appear. So in alternative 1, we do have a frequency, right? We have level 2, which is why this is coded as 010. And for alternative 3, we have level 3 as our frequency, so that's why it's 001. But for alternatives 2 and 4, our car and our walking, we don't have a frequency of leaving, so they are coded as 000. This is just kind of what's under the hood. Sometimes our really mathematical, statistically savvy people want to know what's happening here. Other times you can just trust what's happening in the software. But in terms of the usage, part worth estimation feels no different than for regular CBC, lane class, or HB when using alternative specific designs. The alternative specific effects are not generic main effects, but they're conditional upon levels of the primary attribute they were displayed with. So that's pretty cool. A little bit different than what that conditional pricing kind of talks about. And just know that your standard errors of conditional effects are probably going to be larger for those, much larger for the alternatives than they are going to be for the common attributes, right? Because the common attributes, everybody's going to respond to all of them on every single screen, where our alternative attributes might only appear in 1 or 2 out of the 4 concepts on each screen. So you're going to have wider confidence intervals around those alternative effects. So that brings us to the end of part 1. Don't forget to join us next week for part 2 when we get even more fancy and we talk about partial profile, another way to solve for a large number of attributes versus ACBC. We'll also talk about shelf sets and free format CBC, which is super powerful. Really hope to sharpen up your CSS, HTML, Perl, SSI script skills. Free format is for you. Each of those partial profile, shelf sets, and alternative specific, again, are only available with the CBC Advanced Design module. So if you're on the regular CBC and you've been enthralled by what we've taught you today, let us know if you want to move up to the CBC Advanced Design module. And hopefully we will see you next week. I think we have a couple minutes for any additional questions if you want to stay on the line. Brian, did anything else come in that we want to talk about?
No, nothing so far. Megan and I will hang out for a few more minutes if anyone does have any questions. And just a reminder, if you aren't sure if you have some of this advanced design module stuff, or if you have any questions or anything, you can email us there. Our individual emails are up on the screen, and you can also use our general email, which is support@sawtoothsoftware.com, and that goes into one of our case management systems, so someone on the client services team will get back at you. So feel free to reach out if you have any questions.
Okay, thanks everybody for joining, and we look forward to seeing you next week at our next Sawtooth Software webinar. Take care.